Good evening, everyone. This one is thermal physics multiple choice question test discussion. In the first question, a gas syringe containing a fixed mass of air, the volume of air is 240 cm cube. It exerted a pressure of 5 exponent 4 Pascal. The air is slowly compressed and keeping the temperature constant, the pressure is 1 exponent 5. What is the final volume? So you will use a Boyle's law. According to the Boyle's law, we have P1 V1 equals P2 V2. So first pressure is 5 exponent 4. First volume is 240. Second pressure is 1.5 exponent 5. And the second volume is V2, we don't know. So 1.5 exponent 5 is multiplied with V2. Other side it will divide. So when we substitute the values, the final answer will be B. In the next question, an extremely large increase in pressure is needed to compress the liquid. A gas can be compressed much easily by a much smaller increase in pressure. Which statement explain this? Like why it is difficult to compress the liquids? Because basically in a liquid, the particles are closer. They can move around each other, but they're closer to each other. So as the particles are closer to each other, these particles tend to repel each other. That's why they're applying an outward force, so it is difficult to compress them. But what happens in liquids? In liquid, the particle in gases, the particles are far away from each other. So as the particles are far away from each other, less repulsion between the particles, so it is easy to compress them. So what is the reason? The molecule repel each other very strongly when they're close. That's true. The attractive force between the molecules are smaller at a large distance, but that's because between the molecule they don't have attractive force, they have repulsive force. So that's why this statement, the force is weaker as the distance increase, but that's not attractive, that's a repulsive force. The molecule in a gas, the molecule in the gas collide with the walls of container and rebound. So that is explaining the pressure exerted by the gas, but does not explain about the liquid. The molecule of the liquid are constantly moving at random. So molecules in a liquid can move around each other. The statement which explain this, a molecule repel each other very strongly when they are closer to each other, and due to this repulsion there is an outward force, so that's why it is difficult to compress the liquid. But in gases, because the molecules repelling but very weak repulsion is there, as the molecules are far away from each other, so it is easy to compress the gases. A dish of a liquid is left on a lab bench. Some of the liquid evaporate. What happened and why? The liquid cool because the liquid molecules have more potential energy than the gas molecule. The liquid cool because the faster moving molecules escape. So basically in evaporation, what happened? Most energetic molecules at the surface of the liquid escape, and the molecules which are left behind, they have low energy. So the liquid will cool down. That's why we call evaporation as a cooling process, because the most energetic molecules at the surface will escape. That is why B is the right answer. A solid wax is melted in a boiling tube and then allowed to cool. So when solid wax is melted, means it converted into liquid. And whenever the temperature is changing, the state does not change. But when the temperature is constant, it means the state is changing. Here, liquid is converting into solid. And again, the temperature start to change. What it shows as the temperature is changing, what it shows that, and then why this is a constant temperature, why this point is a constant, it means it reaches a room temperature as it cool down until it will come in thermal equilibrium. So here the state is not changing because we only a solid wax is melted in a boiling. So we melt the solid wax. So it is in a liquid state. So originally is in a liquid state, and when the temperature become constant, it means the liquid is changing into solid. So if liquid is changing into solid, so option B is the right answer. The liquid is turning to solid. What is meant by heat capacity of a solid object? So definition of the heat capacity: the maximum thermal energy stored per, because the heat capacity or thermal capacity is energy divided by change in temperature. So that's wrong, not about mass. Maximum energy per unit volume, that's wrong. Thermal energy required to cause a unit rise in temperature, that's true. This is amount of energy required to change the temperature of given mass by 1 degree centigrade or 1 Kelvin. Then the distance between the ice point and the steam point liquid in a glass thermometer is 20 centimeters. So ice point is refers to 0 degree centigrade and steam point is refers to 100 degree centigrade, and the distance between them is 20 centimeter. In the question, the top of a liquid thread is 12 centimeter above the ice point. So means the liquid rise in the capillary and it rises 12 centimeter above the ice point. So you need a temperature. So basically to get this temperature, because 100 degrees are represented by 20 centimeter, so x degree is represented by 12 centimeter. Cross multiply. So x is equals to 100 multiplied by 12 divided by 20. This will cancel 6. 6 multiplied by 10, that's 60. So B will be the answer. A thermocouple is a type of a thermocouple is a type of thermometer. Which statement is correct about the thermocouple? It can measure a rapid change in temperature. That's true. Like fast change in temperature. It must be made of three. It is made up of two different metal. Its resistance decreases when one junction is heated. It consists of metal, and for metal, in block 4, we will discuss that temperature and resistance are directly proportional for metal. So this statement is wrong. The distance between the two junction increases as the temperature increase. It's not like about the expansion. Like expansion does not happen. So it occur, but that's a negligible expansion. So this does not make sense to the thermocouple. So A is the right answer. A heater is designed to radiate the thermal energy, give out thermal energy. Which change to the design decrease the thermal energy emitted by the radiation? So basically, smooth and shiny surfaces are good reflector, poor absorber, and poor emitter. So if we make it surface shinier, if we make it shiny, what happen? It will absorb less amount of energy. As it absorb less amount of energy, it will radiate also smaller amount of energy, because we want to decrease the energy emitted out by that heater. Which statement explain how a pressure is exerted by the gas on a container? So basically, how the gas molecules are exerting pressure on the container. So gas molecules are moving randomly, they collide with the wall of the container, they changes the momentum, and that is responsible for the pressure. So the gas molecule collide with the wall of the container. The gas molecule collide with other gas molecule in the container when they are colliding with each other, but that is not responsible for pressure on the container. A gas molecule exert attractive force on each other. That's wrong. The gas molecule exert repulsive force on each other, but this statement is true. But this statement does not explain how they exert pressure on the wall of the container. When a liquid evaporates, the molecule escape from its surface. Which molecule escape and what happened to average kinetic energy of remaining? Because the most energetic molecules gain energy from the surrounding and escape. So molecules which are left behind have low energy. So as they have low energy, it will cool down. So what happened to the kinetic energy of the molecules which are left? The kinetic energy decrease. And the most energetic molecule will escape. So most energetic molecule will escape and the average kinetic energy of the molecule which are left decreases. What are the names for the changes of state from P, Q, R, and S? A gas is changing into liquid. That's condensation. So P is condensation. A can be answer or B. A liquid is changing into solid. A liquid change to solid. That's freezing or solidification. Solid changing into liquid. R is melting. Liquid changing to gas. That's boiling. So B is the right answer. A boiling liquid absorb a thermal energy at a rate. So this is a power is given. The specific latent heat of vaporization is 2.7 exponent 6. How much liquid is vaporized in 9 minutes? Whenever you have a question related to latent heat, the time should always be in seconds. Like when power is there, so time should be in seconds. So first we will find how much energy is supplied. To get the energy supplied, energy is power multiplied by time. So power is 450 and the time is 9 minutes multiplied by 60. That will give us energy. And the formula latent heat is equals to energy divided by mass. So mass is equals to energy divided by latent heat. Energy is 450 into 9 into 60 divided by latent heat, which is 2.7 exponent 6. When we substitute the final answer, that answer will be in, because we are using the SI unit, so we'll get the mass in kilogram, as this value is given in joule per kilogram. So first we'll get the answer in kilogram, but all the answers you can see are written in grams. So as these answers are written in grams, so what we will do, we'll convert kilogram into gram after getting the mass. That will be 90 gram. What makes a clinical thermometer suitable for measuring a small change in a so whenever you want to record the small change in temperature, means you want the thermometer to be sensitive. And how you increase the sensitivity? By using a thin capillary or a narrow capillary. That's why B is the right answer. Longer capillary will affect the range. The glass bulb of thin wall, that will affect the responsiveness or quick acting. The amount of liquid in the bulb is smaller. So if the amount of liquid in the bulb is less, so this reduces the sensitivity. If you use greater amount of liquid, it increases the sensitivity. Which statement about the transfer of thermal energy is correct? So how the thermal energy can be transferred? A transfer of radiation does not require a medium. That's true. Transfer is from a region of lower temperature to higher. That's wrong. Heat energy transfer always from higher temperature to lower temperature. Transfer upward in a fluid mainly through vibration of neighboring molecule, not vibration. It is by actual movement of the particle in a fluid. Transfer in solid by mean of density change. That density change is convection, but in solid it happen as a conduction. So A is the right answer. The piston is pulled out of distance 30 centimeters so that the length of a gas in a column is now 50 centimeter. The temperature does not change. So again, we'll use the formula P1 V1 equals P2 V2. But here the volume is not given, the lengths are given. But as you can see, the area is constant. So I can say P1 area into L1 is equals to P2 area into L2. Area will cancel with area. So basically, if lengths are given and area remain constant, so we can also use this formula P1 L1 equal P2 L2. So that does not make difference. So first P1, so we can say P1 L1 is equals to P2 L2. So P1 is the first pressure we don't know. So that's P multiplied by L1, that's 20. P2 we don't know, and L2 is given 50. We need P2, so 50 will go there in division. So 20 divided by 50, 0 will cancel with 0. 2 divided by 5, that's equal to 0.4. So P2 is equals to 0.4 P. That's why A is a right answer. So whenever area is kept constant, the change in the length will cause the change in the volume. So instead of using P1 V1 equal P2 V2, so we can use P1 L1 equal P2 L2. The diagram represents 4 thermometers. Which thermometer has a greatest sensitivity? Sensitivity means maximum distance between the 1 degree mark on a thermometer. That refers to sensitivity. So if you check, this is a 1 degree mark. For thermometer Q, this is a 1 degree mark. For thermometer R, it will be very small because 0 to 50, the second mark is at 50, so very small difference between the 1 degree. And here 100 and 140, the first mark is 120, so it is also having a smaller amount of distance between 1 degree mark. So which thermometer is more sensitive? So Q appear to be more sensitive. And which is having the highest range? Range refers to difference between the maximum and the minimum value which the thermometer can record. So for P, it's starting with 0 and maximum it can be 25, so it's 25. For Q, it started with 30 and the end point is 40, so it's only measure 10 degrees. For R, it started with 0 and maximum is 250, so it can record 250 divisions. It started with 100 and ending at 300, so it means it can record 200. So which of them is having the highest range? So R is having the highest range. And which is more sensitive? Q is more sensitive. That's why option C is the right answer. Which type of thermometer is used in measuring a temperature above 1000? So because liquid in a glass thermometer, the liquids which we are using, mercury and alcohol, and the boiling point is less than 1000. So if the temperature is 1000, it will convert these liquids into vapor. So we cannot use them. So thermocouple is the best, and measuring a temperature change rapidly, fast, quick acting. So both cases thermocouple is the suitable. An electric shower takes a cold water, so that's the starting temperature T1, and shower gives 6000 joules of energy and heat the water to a temperature of 37. The specific heat capacity of a water is 4200. What is the mass of hot water supplied by the shower in 1 second? So basically we have this formula: energy supplied or specific heat, Q is equals to Cm delta T, or C is equals to energy divided by M delta T. So if we need M, so M is equals to E, the energy supplied, specific heat, and delta T is the change in temperature. 6000 joules of energy supplied, specific heat is 4200, and the temperature change, the final is 37 and the initial is 17. So temperature change will be 20 degrees. After substituting these values, the mass appear to be 0.071 kilogram. What is latent heat of vaporization? Latent heat of vaporization or latent heat of fusion, it's amount of energy required to change 1 kilogram of substance without changing a temperature. If it is fusion, it is solid to liquid, and if it's vaporization, it is from liquid to gas. So in a vaporization, basically we are changing liquid to gas, so we are increasing the distance between the molecule. Energy required to make molecule expand. That's totally wrong. Molecules cannot be expanded. The substance, like a solid, liquid, or gas, can expand, but not the molecule. Molecular size remain same. Energy required to make the molecule expand and move up. Move apart is right, but molecule cannot be expanded. So that's why this statement is wrong. Energy required to make the molecule move apart, that's true. Energy required to make molecule move faster, that's move faster is for changing temperature. But in latent heat, there is no change in temperature, there is change in state only. That is why C is the correct answer. Air is trapped in the cylinder by a piston. The pressure is P and the volume is, the length of air is 20. The piston is moved outward by increased by 40. If it increased by 40, so what is the new length? The new length is 60. So what is the new pressure? So we will use the formula P1 V1. But here length is given, so P1 L1 is equals to P2 L2. First pressure is P, first length is 20. Second pressure is P2 and second length is 60, not 40. Because 40 is an increase in length, but the total is 60. So 20 divided by 60, cross multiply. 2 divided by 6, so it will be 1 by 3 or P by 3. A copper rod is heated at one end. So when we are heating a copper rod at one end, how the energies, which statement describe how the energy transfer in copper? Energetic copper molecule does not move, that's wrong. Energetic copper molecule move, that's also wrong. Energetic free electron move from cooler end to hotter end, that's wrong because they move from hotter end to cooler end. That's why D is a right statement. If we want to make a thermometer sensitive, so we should use a narrow capillary or use a large bulb to make it sensitive, which increase the amount of liquid. So what should be done? Like what affects the sensitivity of the thermometer? So the diameter of the bore or the capillary. And this is a clinical thermometer. So why there's a constriction in a clinical thermometer? As the object is hot, the liquid absorb energy and it expands. So as the liquid will expand, it will rise in the capillary. But as the thermometer is now not in contact with the surface, so the liquid will contract. But as the liquid contract, it will not move or return back to the bulb. Why it cannot return back to the bulb? Because of this constriction. So we will have a record of a temperature, that what was the last temperature recorded on this thermometer. Centimeter scale is fixed next to an unmarked mercury in a glass thermometer. Ice point and steam points are, ice point means 0 degree centigrade and steam point is 100. What is the temperature shown in the thermometer? So from ice point to steam point, because ice point is 1 centimeter and steam point is 11. So it is 10 centimeter between them. And from 1 to 6.6, so that this is not, this will be 5.6 because we always take a distance from the ice point. So if 100 centimeter or 100 degrees are represented by 10 centimeters, so x degree represented by 5.6. So you will cross multiply. When you cross multiply, you will get 56 as the answer. The temperature shown by a mercury in a glass thermometer increases. Which of the following is constant? Density is mass over volume. because as it expands, volume increase, so density decreases, so it's not constant. Internal energy, to absorb energy, so it will have high internal energy. Mass remain constant, mass of a mercury does not change. Volume also changes. At temperature increase, expand. If temperature decrease, it contract. Which factor affects the sensitivity of a thermometer? Again, the length of a glass tube, thickness of the glass and wall, and volume. So volume of a mercury, if you use a larger volume, it will have a greater expansion. It increases the sensitivity of thermometer. The other factor, constriction, just only record the temperature, like does not allow the liquid to flow back into the bulb. The length of a glass tube affects the range. The thickness of the glass in the ball of bulb affects the responsiveness. The length of a mercury in a bore of a thermometer is 5 centimeter at 0 and 11 centimeter at 60. What is the length in the bore when the temperature is minus 10? So basically, first what we will do, like if this was a capillary, when it is 0 degree centigrade, it is 5 centimeter above. When it is 60 degree centigrade, it is at 11 centimeter mark. So what is the distance between them? Because this is 5, this one is 11, so difference 11 minus 5, so this is 6 centimeter. So basically 6 centimeter, 60 degrees are representing 1 centimeter, 6 centimeter. So 1 degree is equals to x cross multiply, so 60 divided by 6. So 1 degree is equals to this, because 60 degrees is represented by 6 centimeters. So if I need 1 degree, or if I want 10 degrees, basically 60 is equals to 6 centimeters, so 10 degrees x. So if I need this x, so x will be equal to 10 multiplied by 6 divided by 60. So that is equals to 1. So if basically 10 degrees represented, because we need minus 10. So if it is minus 10, so cross multiply, it is minus 1 centimeter. So from 0 mark, it is minus 1 centimeter. Minus 1 centimeter means below. So the question is, what is the length in the bore when the temperature is minus 10? So minus 10 means it will be 1 centimeter below the 0 mark. But what is the length in the capillary? Because that's a question, like length of the liquid in the capillary. So length of liquid in a capillary will be 4, because minus 10 will be here. So minus 10 is 1 centimeter below. So total is 5. So 5 minus 1, what we'll get? We'll get 4 centimeter. When a person climb out, of warm swimming pool on a hot summer day, he feel cold. Why does? Because what happened? That's due to the evaporation. The water, actually the most energetic molecules of the water taking energy from the body and escape. So this is due to evaporation. 4 syringes containing air at atmospheric pressure. The air in all 4 syringes slowly compress. So volume is decreased. The relation between volume and pressure, if the temperature is kept constant, they are inverse. So means if volume is divided, the pressure will be multiplied. What happened? 50 become 10. If 50 become 10, it means it is divided by 5. So for first one, if volume is divided by 5, the pressure will be multiplied. In option A, the pressure is multiplied by 5. In option B, 100 become 50, so it is divided by 2. So if it is divided by 2, so pressure is multiplied by 2. 400 become 25. So by what factor it is changed? So it changes because 400, if it is divided by 16, we'll get 25. So If this one is divided by 16, the pressure will be multiplied by 16. 400 become 100, so it means it is divided by 4. If divided by 4, the pressure will be multiplied by 4. So question is, in which uh, syringe shows the smallest pressure change? So smallest pressure change is in B. Basically, if volume is divided, pressure will be multiplied. They are inversely proportional to each other. When a gas is rapidly compressed to a smaller volume, its temperature increases. What happened to the gas molecule? So if the temperature increases, it means the molecules will move faster, and a gas molecule is compressed. So if it is compressed, the molecules come closer and the temperature increase. So as the temperature increase, it means the particle will have more collision. So they will move closer to each other, and average speed or average kinetic energy will increase, because temperature and kinetic energy are directly proportional to each other. On a hot day, the drink in the bottle cap can be kept cool by standing in a bowl of a water and placing a wet cloth over it. What is the reason for that? Because that's a process of evaporation. The energetic molecule, as water molecules escape, like this is a container and we have a bottle, and that bottle is covered with a cloth. So when evaporation occur, it will take energy. So the bottle, the liquid which is inside the bottle will remain cool. So water evaporate from the cloth and cool the drink. Question 31. A student used double wall glass vessel uh, to contain a hot liquid. Hot liquid is there, space is there between them, and air is outside. What reduces the heat loss by radiation? How we can reduce the heat loss? Like we don't I want the heat to escape by radiation. So how we can reduce that? Vacuum in a space between, if there's a vacuum, radiation can pass through vacuum, so that is not suitable. Paint the surface Q black. If we paint it black, the dull and dark surfaces are good absorber and good emitter. So it will absorb more energy and it will emit out greater amount of energy. So that will not be true. Paint the surface R black. If we paint it R black, so R will absorb too much energy and it will radiate or give out too much energy. So it will not be suitable. Paint the surface as shiny. So if we paint it shiny, what will happen? Even some of the radiations, like radiation, because are not able to, they will bounce back. Even if they are from outside or inside, it will bounce back. That's why D is the right answer. What is the reason for constriction in a clinical thermometer? What is the reason? Because it does not allow the liquid to return back. So it will stop the mercury or a liquid to going back to the bulb, and it can record the temperature. As you can see, I already discussed this part, mentioned this part, that why there's a constriction in a, this constriction is there because what happened, like example, if we are, say, we are measuring a body temperature, which is normal body temperature around 37. But for example, if a person is having a fever, so its body temperature will be higher. But when a thermometer lose a contact with a human body, then it will record the surrounding temperature. So we cannot record the temperature easily. That is why there's a constriction, that when a thermometer is in contact with the body, it will take the energy from the body and the liquid in the capillary will expand. But once it is outside, it loses a contact. So as the liquid start to contract, if a liquid start to contract, so what happened? Then the liquid will return back to the bulb. So the temperature will not be accurate. So we don't allow the liquid to return back to the bulb. That's why there is a constriction. So to stop the mercury from going back to the bulb. Less heat is needed to raise a temperature of 1 kilogram of copper than 1 kilogram of water. Which statement is correct? So basically it is related to specific heat. You have the formula. Thermal conduction is how much time it will take to transfer heat energy. So specific heat is equals to E divided by M delta T. The relation between energy and specific heat are directly proportional. If small amount of energy, small specific heat capacity. So copper specific heat capacity is lower than of water. That's why it required a small amount of energy for the same change in temperature and same masses. Because the mass is 1 kilogram, temperature change is also 1 degree. So basically the change in energy will decide the specific heat capacity. A person cannot unscrew a metal lid on a pot of a jam. The lid can be unscrewed after after it has been held under hot water, hot running water for few seconds. Because what happened? The hot water will cause expansion. So the hot water will cause expansion. So the metal lid will expand and it will lose a contact with the jar. How does the heat transfer through a vacuum take place? Through a vacuum, only radiation can happen. Conduction and convection require the particles. Which row explain why liquid has a fixed volume but does not have a fixed shape? So force between the molecules and the liquid, it's a comparison. So force between the molecule or liquid because they have a fixed volume, but they don't have fixed shape. Because the particle can move around each other, but still why fixed volume shows that the force is stronger. Otherwise, if force is weaker, then it will not have a fixed volume. The molecule can move far away from each other. To raise a temperature of 2 kilogram block by 20 degree, 5.2 kilojoule is needed. What is the value of the specific heat capacity? This is kilojoule. So 5.2 kilojoule means 5.2 multiplied by 1000. So it will be 5200 joules. The temperature change is 20 and the mass is 2 kg. We need specific heat capacity is energy 5200 divided by mass, which is 2 divided by change in temperature, which is 20. So when you substitute these values, C will be the right answer. What makes a clinical thermometer suitable for small? Whenever we want to measure a small change in temperature, we want the thermometer to be sensitive. So how we can make a thermometer sensitive? By changing the like size of the capillary using a narrow bore, or use larger amount. The amount of mercury in the bulb should not be small, it should be larger if we want to make it sensitive. So that's why B is a correct statement. 4 beakers containing equal volume of water at 2 different temperatures. The beaker are placed in open air, from which beaker does water evaporate faster? Surface area, large surface area and high temperature, rate of evaporation will be, because large surface area, so more molecules are exposed, and higher temperature, the molecule have more energy, so they can escape faster. The fixed mass of a gas undergo a change in volume at a constant temperature. Which graph shows a relation between pressure? Pressure and volume are inversely proportional. So if two quantities are inversely proportional, it will be a curve. If one quantity increase, other decrease, but it will not be a straight line, it will be a curve. So option D is the right answer. So this was the thermal physics multiple choice question test discussion. Hope you understand all the MCQs which I discussed. If you still find any of the MCQ it's not clear to you, you can let me know in a chat.